All right, good evening, everybody. So welcome back to the Design Lecture Series. This is gonna be our last lecture this semester. And thanks for being here, even if you have all the exams and other appointments. So thanks a lot, guys, for being here today. And we have another friend of the Rome Center, Simone Rossi. He will give a lecture, very interesting as well, about wood as a building material between tradition and innovation. Who is Simone Rossi? He worked since 2012 in the field of timber engineering, both as a lecturer and as a researcher in different universities in Italy, Sweden, Canada, and contemporarily as a consultant. In 2015, he earned a Ph.D. in civil, mechanical, and structural engineering, focusing on analyzing the systemic behavior of multi-storey timber buildings. He also worked as a structural engineer for a multinational engineering company, specifically on the design of timber, steel large span structures, and facade systems. In 2017, he joined the Rubner Group as a structural engineer and project manager. Since 2019, he has been the head of the technical office of the Bressanone affiliate, leading a team of 40 professionals, including engineers, architects like you, and designers. If you're interested in the Rubner as a company, and I suggest to go and have a look at the internet site, you just need to go on rubner.com. But now let's make the story short. I'm going to give the stage to Simone. Thanks for being here and for accepting our invitation. He came directly this morning from the north of Italy. He woke up 5 o'clock in the morning to be here with us. And honestly speaking, we particularly appreciate. So thanks. The stage is yours, Simone.
Thank you, Francesca, for the kind introduction. Good afternoon to everybody. First of all, I would like to thank Professor Francesca Ricciardo and Professor Bedeschi for the invitation. It's a pleasure for me being here, although I'm a bit sick because my little guy is taking on some flu. By the way, I would like you to think at this small presentation not as a lecture, but as a point of exchange idea. And then if you have a question, feel free to give it to me. I'm not that old, so I will reply quite, how can I say, happily. So you already know who I am, so I will skip this part. The presentation consists of 5 different sections. I will briefly provide you some information about the Rubner Group, as it is not that easy to understand who we are and what we are doing. Then I will let you understand what are our main products, how do we make business, what is our competitive strategy in the field of timber engineering. Then I will present you 2 different case studies. The first one is the sport hall of the Dertona basket using the DFMA approach of design. Then we will have a brief look about the Merlata Bloom, the largest shopping mall in Europe, recently completed in Milan. And we have been part on the design of it using a computational design approach. And then I hope we can have a funny part about question and answer. Let's start with the Rubner Group. Rubner, it's a group of 24 different affiliated companies working in the field of timber engineering in Europe, although we are an international company because we are quite active in the entire world. These 24 affiliates are placed in 15 different locations and 4 countries. We are more than 1,500 employees, and we have a total turnover of more than 400,000 million euro. These 24 different companies are grouped into 4 different business segments. We have the first part, the wood industry, those companies that take care about the raw products. Then we have the sector of small single family and double family houses, namely residential application. Then there are the part of the company that produces finite products such as window and door, a very high quality level windows and door. And then there is probably the most interesting part of the company, not because I'm working for that, but because of the type of structure we are taking care, namely tall buildings, large span structure, iconic building, or whatever called timber engineering. What is extremely interesting and makes us unique is that the 24 companies, although they are making business in a standing alone point of view, they must be profitable. We are vertically integrated. Here you have a small picture showing more or less how we working. So we take care about the forest, we manage it, we own it, we take the log, we produce the lamination and the raw material, and then all along the value chain, this raw material is taken up to a finite configuration, building, window, door, building, or whatever. What are our main products? So basically, the raw material that is wood, timber, as it is engineered, made of larch or Norway spruce. We produce glulam beam, is GLT, cross-laminated timber, and then framed elements. These three base products can be combined. We combine them into different applications in the factory, in the workshop, creating a semi-finite product, a kind of kit for structure, for exterior wall, interior wall. Namely, how can I say, staging between the final configuration and the base product. This activity is performed, is pursued through 4 common steps, generally speaking. We start working with architects or design team of the client with the conceptual design, working shoulder by shoulder. Then we further develop the design, the planning, the project management, and the production, direction, and the installation. This activity that works on those 3 base products are basically articulated toward 4 main business models. So these are the more important business models for us. Residential multi-story building, and the picture you are looking at, this one, is the tallest timber building in Germany, recently completed in Hamburg. Then we have industrial building. This is the headquarters of Tetra Pak in Italy. We have prefabricated timber facades and also individual construction. From a strategic perspective, maybe it's not that common as a description. Using the Porter generic model, we as a company pursues our main ability, our core competencies through what is called differentiation strategy. Each company is making business addressing 4 perspectives. We are looking at differentiation strategy because we are, I would say, quite good in integrated design, in developing tailor-made solution, addressing the client expectation, and also the integration of the group. What means differentiation strategy? It means that we are targeting a wide sector of the market. That is why we are active in the entire world, but with a different approach. We are not a mass producer, although our production is quite high, but we try at the beginning of the design to understand what the architect, the client, the design team is looking at, and we try to commute to, how can I say, develop our base product, the kit, to successfully make the client happy. This is quite high from the point of view of the description, but basically, what do we do, especially in the technical office, the office I'm leading? We work on the conceptual design, the preliminary design, the engineering design, and the final design. What is called integrated design from the beginning up to the analysis of direction. In a nutshell, what do? We take an idea, starting working with the architect, shoulder by shoulder, and try to make it real. And that is the picture of there is a delay. Okay, sorry. we try to create what the architect is looking at. That's the Azerbaijan pavilion we developed for the Expo 2021 in Dubai. Exactly. Looking at the picture, everything seems quite easy, but it is not, because we are a designer, a producer, we install it, we help the client to maintain the building. And so I let you imagine how it's difficult to take product through the entire world. It is physically a nightmare because of custom duty, specific regulation. You have to fit everything in a container. So although the building, the pavilion, or the structure is quite large and tall, you need to split up every pieces in smaller pieces, long, high, at maximum 11 meter. We need also to design every single nail, steel harder, whatever there is in the building. Yeah, okay. Sorry, there is a delay. I'm looking at the screen. I apologize. We need to design everything because as I told you, we are developing a tailor-made solution. We cannot use out-of-shelf hardware. There are plenty different thousand producers that produces angle brackets or the like or whatever it is. But if, as Rubner would like to address the client expectation, the architect expectation, we need to design also the very small base plate or steel hardware. Not only, there are state-of-art, there are limitations in the production. That is the pavilion we have just seen. It consists of several different branches, each of which is different from the other. And the curvature of these elements are smaller than the real production capability, because I'm bending toward my engineering part of the brain. Whenever you bend a piece of timber, you are introducing a stress. And then if since the beginning you introduce a stress, you are decreasing actually the load-bearing capability. Thus, there is a limitation. In this case, many of the branches were too narrow for this limitation. So if you look at the picture, look at the pointer, you can see here in this zone 3 different lines. The first one was the line in the final configuration, the radius that the architect wanted for the branches, and the other one was the dimension of the row piece, and then we carved out everything. This is extremely challenging from the point of view of the drawing, the fabrication, but also from the structural design, as timber is a fiber material, and then you cannot cut the fiber, otherwise you are diminishing quite importantly the ability to take load of the piece. And not only, we have to take care about also the transportation, because you cannot design the building without taking out from the factory the piece and take on the road, on the boat, or also with the helicopter sometimes. Okay, first case study. I'm going to present you the Daytona Basket Sport Hall. We developed it with the design for manufacturing and assembly approach. It's a quite interesting structure, and it is going to help me in try to explain you how do we work, how can trace of everything, how can organize everything. You're looking at an engineering drawing. We designed and installed the roof of the sport hall. It's a dome, 80 meter in diameter, so quite big. That's a screenshot of the drawing we exchanged with the client, so it is physically a part of our design. And the roof consists of 2 main trusses. Here on the left picture, you can feel them here on my pointer, that are taking the load of the entire roof. We have 3 bays. The central one is 33 meter large. How do we get to the final project? Through the drawings, but also the structural calculation. This picture is showing you the final finite element model that has been quite complicated to correctly model and consider the interaction between the foundation, the concrete shaft, the concrete shell, and also the roof, as the Daytona Basket is playing in Pavia, a quite seismic prone region in Italy, thus the seismic action led the design. Another picture of the finite element model, so you can also feel that there is a quite superposition between the design, the structural design, and the drawing design. As an example, we had also to take care about the action of the wind while installing the structure, or the info screen that has been installed in the middle. Here you see here 3 steel beam that has been designed to carry the load of the info screen for the games. And I had already told you that we designed everything. I took some screenshot from the structural report we gave to the authorities for getting the approval for the construction. So one more time, 2 pieces of the reactivity on the left. You can see the stress in the element, and we designed each single nail physically. We are speaking about a structure 80 meters in diameter, but we need to design, procure, take to the site and install each single nail, each single pin, each single dowel. This activity ends with the development of a 3D model that is not actually only a 3D model, but it is what we call a digital twin. You are looking at the shape. I took a cross-section, and you are looking at the real structure. But this is a model. It is a pivotal item for our activity because it is used to take engineering drawing to the client, so you can extract the drawing, but it holds all the information, not only for the timber, because it is used for the clash detection, to order all the material, so make the bill of quantity.
Is this a sort of BIM or is it more than a BIM model?
Actually, it is a BIM model. We use a proprietary software that can discuss with the CNC machine, but it holds a lot of information, such as color, strand class, type of timber, when you need it on site, what is the name and family name of the element we are going to see it, everything. That is why I call pivotal element. And thank you for the question. Here you have an example. This is the final configuration of the model. I highlighted this green beam, and it's not that big, but on the right side, you can see that we have all the information about this beam. I can interrogate the model, and I know that this beam is 24 centimeter wide, 2.6 meter tall, 32 meter long, is created in glulam GL30C. I know that there are five elements in the building called this type of beam, and also the assembly mark. It is not only used for the installation, but also for the production. That's an engineering drawing. If we look at that beam, here you can see that that beam has a positioning number 15008, and this is needed to instruct a production to create that beam. So we need to provide our production with what is called in German press bed. No, that is English, sorry. Press bed or Pressbetten in German. So namely, you need to instruct the production what is the shape of the beam, how long is it, how much does it weigh, and also in our logistic system 15008, you see here, once again, I know the type of timber, type of glue, how much does it weigh, how it is long, when I need it to have it on site. So everything is taken under control with this pivotal element. But not only on the team, only on timber element. We need to do the same also with the steel hardware. You see that is the central steel plate for the truss. Maybe it's not that easy to read it for you, so I can help you. This small guy is 4 meters long to connect the two pieces of the truss, and it weighed 1 ton, 100 kilograms. That's the digital representation of the element, and I took a picture of it. Then everything is taken on site, assembled, then we tilted up the truss and put on its final place. I have a couple of pictures in order to make you understand and feel how big is it. So that is the dome. And if you look at the pointer, I just took a snapshot of this zone. So here we have our carpenter working on the roof. So you can physically feel how big is it. And finally, a small video of the erection site that one of our carpenter took during the installation. While looking at it, we always struggle at the beginning of the design because usually we get on site later on than other contractor, and you need to agree with the partner on the side about the lifting equipment. So you need also to take under control the weight of the element and how far is the weight from its final configuration. It's not, how can I say, such an easy task actually. And although it seems probably a detail, but it is not. Okay, other example. I'm going to present you the Merlata Bloom Milano in Milan. This is the largest shopping mall in Europe. We have been quite lucky, let me say that, to work on it, although it has been quite a nightmare. We worked on it 3 years, and we addressed the final request of the architect and the client using a computational design approach. But first of all, I would like you to see at the beast, or at the snake, let me say that, because there is this delay again, sorry. What can I do? Oh, here we go. That's the shopping mall. It consists of 2 pieces, 2 big buildings, and we designed and installed it's called Winter Garden, the gallery connecting the 2 buildings. You see this part that is quite big, but one of the biggest headache we had is that this part of the structure is overtaking next seat of the A4 motorway, the largest motorway in Italy. So we had to install and take care about the safety of the people on the building and also the car underneath while installing it. A couple of information. This shopping mall is placed in the northwest part of Milan, close to the Expo 2015 zone. That is a quite vibrant part of the city because a lot of construction and architectural activity is taking light there. As I told you, the building is quite big. A couple of numbers I took from their website. The building consists of 70,000 square meters of shops, 100 plus shops. 10,000 square meters are dedicated to installation, culture, and also entertainment. And then we have also 20,000 square meters of sky garden. Probably for what is usually done in Europe, it's a quite big and massive activities. It's larger than normal. That's a picture I took from inside, because looking at the global overview, you cannot feel how big is the structure. Basically, the structure is quite challenging, and now you're looking at 2 pictures that represent the most important part for the design and architecture of the building. As on the left part, you see how the building is composed. We have this portal frame, portal frame, placed 3 meters apart, and then we have a cladded part or a closed part, and then we have the window on the other one. But more important is the shape, because if you look at the projection in plan of the building, we will see that we have a double curvature. And then if you look at this picture, we have the ridge line and the gutter line that are going up and down, but not consistently. Why it is so important you to understand that? Because if you take 2 portal frame, place it one close to the other, and then you change the inclination of those elements, and then you consider to project them on a curve, you end up with a surface that is not actually a surface. It's a kind of work surface to be covered with another piece of CLT. So not that easy at all. I can some numbers, some key fact. The gallery is 300 meters long. We have 106 3-inch frame each of which is different. So 106 single piece with a maximum span of 37 meter. We use a total of 2,000 cubic meter of glulam. Just to give you an idea, one full truck can load 50 cubic meter. So we are speaking 2,000 against 50. I let you imagine how many trucks we move from the factory to the center of Milan. 500 cubic meter of CLT, and then 100 tons of steel, custom, self-designed brackets for timber-to-timber connection. To do that, me and my guys working on more than 4,500 drawings. I let you imagine the effort, the energy, how many pills I took for the headache to develop it. 600 single piece drawing for the CLT, 900 drawings for the steel production. And just to give you an idea, it took 1,500 days per man for the installation. If this is not enough, the building is divided in 3 sections. We have the bridge that overtakes the exit of the motorway, and then we have the east part and the west part, because the entire structure is overtaking 2 seismic joint, because Italy is quite a prone seismic region. This is another picture that is helping me to let you understand what is our work and how we addressed it. Here on the left, you're looking at 2 pictures of the same, basically D-Day, because we are looking at the base plate of the frame. And then here on the model, we have the typical detailing, but it is changing portal with portal, because I already told you that each single portal is different. Similarly, at the knee, we have a rigid connection that is taking the force from the beam to the column. So we have a typical detail, but point by point, the detail is different. And there is here a picture showing you the gutter line and the connection. And sorry, I forgot to mention that the part of the building, the structure over the motorway, has been installed nighttime, because for safety we had to close down the exit, but it was not allowed during day. So our guy worked on night, and I let you imagine the difficulty, because we had some people in the factory to address their question, and then they worked during the night, and the perspective, the way you feel the structure is not the same as during the day, because you have artificial light, so you have not that same feeling. And this is another picture. We also perform test for prove that our design was right. So we physically pull down the structure to check the deformation, and then a picture of the almost finished structure. So you can feel it's not that small. Another important aspect of the structure is that since it is a shopping mall, due to European Italian regulation, everything were 90 fire rated. And that is a quite important item to take into consideration between you and me, namely between the architect and the engineer, because I, as an engineer, love large pieces, large bracing or large beam, but it's not that easy to digest from people like you that has a higher level of aesthetic and understanding. So I decided to put this picture, because what we'd like to do is make the client happy and work with the architect shoulder to shoulder, and enriching the experience in between, and probably exchange point of view, culture, and then how can I say, objectives. And we ended up, after a couple of tests, with this solution. So you see at the digital model and the reality, in which the architect accepted to have some large, massive bracing in timber, designed to take the load also during the fire event, and then some small bracing that we designed to be lost during the fire event, but not that big to, how can I say, make less prestigious the facade. And finally, how we designed and installed the shadow panel on the roof. we made 3 different tests, because actually to speed up the process of installation, we decided to pre-assemble, to prefabricate the panel in factory. But those panels, as I told you, were dropped. So we control the different in positioning through a specific method I will let you see, and we check if physically the panel could, how can I say, could physically deform as much as was needed, not only the timber, but so the insulation, the lintel in between, and the metal sheathing on the top. I hope you can understand how difficult was the design, but how a structure like Rubner, although we are quite big, can work on such big project, staying in the time that the contract gave us, that usually it's quite narrow. So usually sales guys do not take care about technical and architectural design. They take care about price and installation, but it is something they cannot feel.
So did you use parametric design?
Exactly. That is the presentation. We decided to perform 3 different types of tasks using a computational design approach. And we diminished the time of design and our activity thanks to 3 applications of computational and parametric design. The first one is the development of the engineering drawing that we are forced to provide the client and the architect for the approval to get the green light to produce all the structure. The second one was the structural design, the development of the drawing, the engineering drawing, the production drawing of the steel hardware at the knee. And the last one, probably most interesting for you and me, for the purpose of this lecture, the development of the as-built B model LOD 500, and then we will look at it. First application, here we have some picture. At the left, I took a screenshot of the script that has been used for the extraction from the model of the cross-section of the portal. I told you that we have 106 different portal frame. I want to make you laugh. Thanks to the main architect, we developed 14 different revisions along 2 years and tried to think how much time, effort, without a real benefit for the company in putting on a 2D drawing of each single portal frame. So we decided to develop a screenshot that was fed with the model, and as an output, we got the drawings, speeding up, extremely squeezing this time. That is basically something needed. It is a must as a milestone in the time schedule, but it is time consuming. The second one, and this was a game changer, honestly, was the design of the hardware to connecting the beam and the post that was designed for taking the bending moment to connect in 2 pieces. Because we decided to develop the script here in the left about these brackets and then the brackets for the gutter in probably halfway of the design. Because we were not that sure it was physically possible. And why was quite something we had to do before, because one more time, we have 106 different portal frame. Each portal frame has 2 knees, and the 2 knees are different. So basically, we structurally designed it, and produced 212 different hardware. If you multiply it by 10, 12, 15 revision, I let you imagine how difficult it was. So we decided to develop this script, and the script task was the structural design and the engineering drawing and the drawing for the production on the bracket. So basically, the computational designer team developed the script, and now the script works. You need to feed the script just with a vector that is an orientated segment, providing physically the conjunction between the post and the beam. And as a result, we got the drawing, the engineering drawing, the production drawing. But not only that, we included in the script also some standard check because I guess you are familiar with the fact that pin, bolts, and screws or whatever it is has a minimum distance along the grain and 90 degree to the grain. So we took under control also not only the structural design, how many pins we needed for taking the force, but also the limitation given by the standard. The last application, maybe not that fancy because you can directly feel the importance that this was extremely important for us, was the development of the as-built model in a BIM format with a LOD level of detailing 500 according to the UK standard. So here you are looking at 4 screenshots. The first one was the roadmap and the gather on the information. We apply it to the model. The script for the parameter mapping and attribution or superposition. Here you see at the model, the final model we deliver to the client, and here a screenshot of the information we have been forced to apply to the model. A couple of comments. A level of 500 is extremely high, namely in the model that it weighs more than 10 gigabytes, just to give you the feeling. Each single nail and each single screw is included, but not only the screw, the head of the screw, the shank, and the threaded part. Literally a nightmare. Probably I gained the paradise working on this project, I hope so. But not only the information that the client wanted, and it was the first time, and just between me and you, I hope it was also the last, not only the first, we included what type of timber, who designed it, who installed it, the name of the company, the email address, the DOP declaration of performance, a phone call, a phone number, street address, positioning number, color, type of finishing, when we produced it, when we installed it, type of warranty, and warranty expire date. Literally an extremely hard work, but not only for the team, but also for all the accessories we installed. I let you imagine how difficult it was, and we could do it only thanks to the parametric design approach. I don't know how, do we have some more time? Okay, because just to let's start the discussion, I have a couple of pictures that maybe are interesting for you with the same approaches. We work on some nice building in the last years. This one is the UK pavilion we developed and designed for the Dubai Exposition 2021. It is a quite interesting structure. That's a picture taken from the model, and that is the reality. The building is quite long. It was 50 meter long, 21 meter tall. And that is the inside of the building. So the building consists of 20 different stories made out of different cassettes. And the idea of the architect that was Devlin, thanks. I will never forget her, because we were forced to work from home because pandemic was running out, and she was in her house taking the tea. Then please cut this part from the record. And then the other one, we already seen it. Okay, cool. The Azerbaijan pavilion, an extremely nice structure. I like it more than the other from just aesthetic. And then the Belgium pavilion, even this one for the expo. I'm let you see those buildings because we use the computational design approach. I can think that you can appreciate quite easily the positive benefit you can get using a parametric or computational design using this building, because there is a rule. Everything can be mapped with a parameter. Is important for us. Thus, you can speed up the process of design and taking under control the quality and the production. And the last one, we are going to install it next year. everything is on site, is on Sydney, is the Sydney Fish Market. If I well remember, you see Francesco some piece on.
We saw the mock-up when we visit the factory with our students. There was the Australian people.
Yeah.
There.
Okay. Right.
I know that the ship made it safely to see.
Yes. Exactly. So that's the picture of the render. Just to, I want you to imagine the process of the design, and everything is involved for us as the contractor of the roof, because the building is 300 meter long, 150 meter large, and basically the roof can be described with a spline with a double curvature. But while you walking or running through the roof along the measured dimension, the two hedges, the two gutter, are moving from one side to the other. So each single piece is different. The roof weighs, in terms of glulam, in almost 2,000 cubic meter of glulam that the contractor wanted to have on site in one bunch. Everything has been forced to be there prior to the installation, because we are going to install the roof from the sea using boats. So we designed everything, we produced everything, we stored off in our company off at the port. Then we load everything in a boat and took it to Sydney. So from a strategic and a managerial point of view, I want you to think about the risk that the company took, because you are speaking about million of euro of goods that are on a single boat.
So where was the production in Amazon?
Yes, in the timber engineering part of the company, there are 4 different companies, 4 affiliates. We in Italy, there is Obergrafen, there is close to Vienna, Austria. One in Augsburg, medium-sized city out of Munich in Germany, and the other one is in France. From Italy, 2 are the production line, one in Italy and the other one is in Vienna. And the 4 affiliates take care about all the world. From Italy, from Bressanone, we take care of clearly Italy, Switzerland, the US, Canada, and the larger America, although in Brazil or in the South America, we are not that active because the dimension of the building. Middle East, such as UEA and Saudi, and then the Far East with Australia and New Zealand. So everything has been designed and produced in Bressanone. No, we took, because of the dimension of the beam, thank you for the question, extremely important for me, I forgot it. The beam, differently than usual approach, has been taken to Australia in the full length, 28, 32, and 35 meters approximately. So we did not load it in a container, because containers are limited to 12 meter long. And we took everything by truck to the port in Venice. So not in a container. We stored it in bunches actually, and we put into the boat. Another exercise we did on this project with the computational design was the installation sequence. I want you to focus a little bit. We have a pool approach in the production because our plot is full. We have not that space to store material. That means that once you finish a beam, you need to load it on a lorry and take it out from the company, especially when you're speaking about long beam. So we took that piece, we put outside of the company, we group it in a bunch, protected with a foil, took it on the truck, stored at the port, loaded in the boat, unloaded at the Sydney port, loaded on a small boat, and then installed. And then when you are going to unveil the bunch, you need to find the right beam you need on site to be lifted. So not we, I say we, but my computational designer that are a great team took care about all this process. We ran 3 different routines with cross-check in order to be sure that once you you take off the plastic foil, you find the right beam. Otherwise, everything will be stuck because you need to stop all the installation. And we are speaking about a quite huge amount of money. Last one, because my time is almost done, I would like to exchange some opinion and question, is the Eric Twiddle Stadium. We won a Timber Award prize in Australia. We are quite active. So in Australia, and although this is not such a big building, I like it because of the architecture, and also we had a quite good exchange with the local design team, and the aesthetical appearance is extremely high because the local architect want to keep an extremely high level of detailing. And also, if you see that at the beam are tapered, but actually the cross-sectional dimension, so the structural part of the beam is the beam are higher, but he wanted to make the overhang as narrow as possible. So we developed what we call, maybe not in the right way, an inverted beam. So you have the statical part that is disappearing in the soft. Sorry, last one, the Chadstone link. One more time, that's a structure in Australia, is a tensile fabric structure. So we have some arches that are snaking through two different shopping malls that they are covered with the fabric. Also, this one is pretty interesting. So, thank you.
All right. Thank you, Simone. It was a great lecture. And thanks for showing us all the tricks behind just a beam.
Okay.
So great, and also very interesting projects, very big scale. So your company is taking care of amazing projects. Guys, is there any question? While you think about a question, I have a question for you, Simone.
If I can, I told Francesca that usually
Yes.
in this situation, I take with me some chocolate to, how can I say, as an icebreaker, a bunch of them, 10, 20 chocolates. So as, how can I say, a small prize, but unfortunately this morning was too early to remember that.
Sono
But
chocolate.
please, let make this, how can I say, kind of dream. So.
Oh, yes. Wait, I gotta come close to you.
So I actually have a lot of questions.
Cool.
But who decides on the thickness of the parts that you're designing? Is it engineering or is it mandated by the program? How much do you rely on these programs? And do we verify this twice, like paper? Let's say other people verified the loads, the stress, everything else. And do you think this was possible just because the AI is so advanced now that before, we didn't build like this. Now we have the possibility of use the timber as we do it now. Is it only possible because of the AI, or is it advanced work from?
Thank you for the question. Extremely interesting. Actually, it's a kind of iterative process. Currently, we are working on AI only on drawings, not on structural design. Our company is soon mid 100 years, so we are quite old. And in Brixen, the first glulam beam has been produced in 1972. So we are the oldest timber producer in Italy. And the thickness of the beam is decided by the structural engineer. There is, in general, a kind of workshop or meeting, especially for interesting project with the architect or the local design team, in order to check if the cross-sectional dimension can be fit into the project. The loading is something that usually is given by the final people using the building or the structure, but also by the code. You have a minimum level in terms of applied load, but also expected performance in terms of vibration, deflection, and life expectancy, appearance, fire reaction, or whatever. Then in this workshop, you agree on this parameter, and we as a company usually provide the client as an approval what is called the base load assumption, in order to understand that is a kind of frame of reference. And starting from that, we physically design. My technical office consists of 40 people divided in 3 groups: computational designer, structural engineer, and draftsman. Although draftsman is not the right word, because they have this pivotal task to do in between the structural engineer, the computational designer, the production installation. But everything is designed by us in terms of cross-sectional dimension, using those parameters as reference. The client can choose the aesthetical appearance, the dimension of the lamination, and the type of timber, large or spruce. If the beam is too big, you have 2 options. And then one is not a possible path, because if the beam is or the column is not big enough, you need to diminish the load, but it's not feasible. You can change the statical scheme, you make another concept of the statical scheme, or change the center-to-center distance. Did I reply?
Hey, great. Thanks a lot, Simone. Is it there any other question?
So you showed,
I think I got a...
you showed an image from a high-rise building in Hamburg. So what are the limitations right now for tall buildings?
Okay, that building is in Germany, in Hamburg, at the Philharmonie port. Sorry, it's strange because whenever I need to speak English, some German is popping out in my brain when I speak German, and some English word is popping out from my mouth. So that building is almost 70 meters tall, more or less. Sorry if I not remember the right number, but the limitation was given by the fire regulation in that specific application. And it is private and public investment activity, because at the base of the building, the headquarters of the Wild Nature World of Germany will move their quarter. So actually you have also residential application, and the fire regulation wanted to have a fire-rated structure, but also a control of fire quite active, so we also install sprinkler. And the facade, if I remember, is treated with retardant painting. So for and because of that, due to the fire regulation, the elevator and stair shaft is in concrete. So in general, the boundary condition are not just one single item, it's a combination of different factors: loading, performances, and also fire. So you do not in general have just one limitation only, but you can move up and down with dimension of the building, and also the ratio in between the height and the dimension in the projection in plan of the building is a leading aspect, because it is clear to understand if you have a wide building, you can make it higher, but if you have a narrow building, then it is more flexible. And then probably if we could move that building from Hamburg to Rome, maybe we can move it 1-to-1, but if we take to Milan or Bologna or whatever it is, probably is not feasible, because the seismic acceleration changes and you need to change it.
Following this last question, so I have two questions for you, Simone. One, obviously, thanks to your presentation, I think it's clear how important is, again, innovative tools in an industry that you said is 100 years old in a way, no? So we're really interesting to see how parametric design and this, algorithmic design it's opening new frontiers. So my first question is, where do you see the limit today? I mean, how we've been talking about artificial intelligence, but here is still the property of the material. So where do you think it's today's limit? And the second question is more related to what we were discussing at lunch about the gap that sometimes there is between the designer and the work that you do. No, you were telling the story about Renzo Piano, and which might be an interesting one to share with the students. So, speaking to future architects, where is this gap? I mean, how good a designer should be in order to get where he wants to be without hitting the wall of you guys saying, I'm sorry, it's not doable.
Okay. Good question. It is not that easy to reply. I will try to articulate a description, but you know, your speech or your idea is only as good as your ability to articulate it. So I will try to reply. First of all, the limitation, I would say, it's sad to say, but is money. Money. Yeah. Because if you have enough money, you can push the limit quite further. Of course, you cannot do whatever you want. That is clear. But the limitation is money, clearly. Then there are limitations in the usage of the material. Timber, I believe it is an extremely interesting material, but you need to use it in a wise manner, because it is at the end of the game a natural material, and it can decay quite fastly. I'm speaking about months if you do something not correct. If you expose it to rapid change in moisture content and sun and shadow, and you do not protect it, it can decay quite easily and fastly. And also it's not that strong as we would like to. It is probably, no, it's not probably, it's 1/10, 1/20 compared to steel. But on the contrary, it is a sustainable material. It is more lightweight. So in some application, it has some great pros against concrete and steel because it is lightweight. I'm speaking about poor quality soil. And for sure, new technology are pushing more further the limitation. I would say that 3 measures step has already taken. The first one is the CAD drawing in general, because when we started, as the dean of the technical department, I often, and when I say often, I meant at least once a week, I've been called from one of our clients for information. Can I open a new window of what happened at a bin has been born, or whatever it is? Because the company is quite large. We are active since many years. And currently we have a ratio about 150, 200 completed structure per year. Multiply this by 10, 20, 30 years. And the first measure changes, the first measure changed has been the use of CAD drawing. That shrink it quite a lot the time of the design. Because when I've been called for an old project, I open a drawing made by hand. The second step that we already experienced is the use of CNC machine. That can help you in carving, creating, opening, double curvature beam, or whatever it is. And you see our machine, we are quite technology driven, because as I told you, we tailor-made the solution to the client. So we must use that technology to address the request of the client. And we are looking to have a new machine, but it is a quite huge investment, not only in terms of money, but positioning and use of it. Because you need to have a quite high experienced guide. Because in order to make the tool be profitable, you do not only need to have the money and buy it, you need to have someone that can properly use it. And for sure, artificial intelligence will help us a lot, but not only artificial intelligence, because I guess you are familiar that artificial intelligence is a quite big container, because you can speak about machine learning, deep learning, algorithm, or whatever it is. But it will be a measure pro. We are already trying some tasks. I don't remember if we let you see in August what we are testing, namely the advanced reality using Virsor. We can superpose the reality with the digital model, creating what is called a phygital experience, physical and digital. And it can be used for now in through 3 different flavor. So engage the client, make it feel the structure. We did it for the Tortona basketball hall. It can be used for the prefabrication of the element. Do you remember I told you that we developed 1,000 and 1,000 of drawing for the production of element? Try to imagine if the carpenters in the factory can wear the visor and superpose the beam with the steel harder and the position of the ball. I do not need to issue the drawing because physically the operator knows directly what he has to do. And the last one is survey check or exchange information with the site. You just need to put some target on site and then superpose the model because you can orientate it with the vector and then you superpose it to check if something is wrong. Task consistency check, quality check, and then instruction for the installation. And although if something gets wrong, because sometimes it happens, and we get a phone call during the night, during the day, and maybe our carpenters are in Australia or in the US, so you have this time gap, and it is clearly not that easy for someone that needs to understand what is the problem and provide a solution maybe at 2 o'clock in the night. If you cannot see what the other guy is looking at, if he could put up the helmet and then you exchange the same view, we are trying it. That's the first point. Is not okay. I told it that to my computational designer Dean Zeno, and although he is not that big, he's look like that. He was shouting at me, "Oh, no, it's not the metaverse. It's advanced reality," because you are not disconnecting from the reality. It's something that I do not properly, how can I say, understand, but he told me that is a superposition. So augmented reality, exactly. So the right word, I was discussing it with the professor for the Polytechnic of Milan. So we are thinking about the IoT application. It is a phygital, so a combination of physical and digital application. And for me, it is quite spot on, this word, a phygital, because you are improving, increasing the quality of information exchange and then the experience.
Right. Great. It was really, really nice. Thanks a lot, Simone.
I want another question from the guy, otherwise I will not let you go. I know that you are quite under pressure because some examen are running on, but just one question. Come on.
Let's see if is there another question. Who's courageous? Ooh, there's no chocolate. I'm sorry.
So I know you mentioned that the company is vertically integrated, and I was wondering if y'all, with the management of the forests, if you are planting like different trees that maybe can accomplish bigger spans, or what kind of options you have in that area.
Thank you for the question. I know I forced it, but it is extremely a good and smart question because it is a not topic in the company because maybe it's not that known that the type of wood is used for the CLT is not the best one. We are using Norway spruce and larch, but the industry uses these 2 type of timber because they are easy to work with. The strength is not that high. As an example, just 2 number. In general, the average value of strength of these 2 species is 10-15 megapascal, but there are different trees such as teak or other wood that can go up to 70 or 100 megapascal. So from the strength and the stiffness point of view, there are different species. The reality is that they are too hard to be cutted, sewn, and glued. Maybe you cannot glue it because the glue is the most important part of the timber. The glue line must be stronger than the timber, but just that small, not that stronger, just as strong as it is enough in order to not lose money. So that we are working on these species because they are dying physically. There are some bugs eating these trees in Italy. Not in Italy, in Europe, there are some fungus that apply that blue stain on the timber that targeted do not like. So it is a quite fragile type of timber. Currently, what is the state of the art? What everybody is doing is close the life of the tree. You harvest it much earlier than before. The result is that the log is smaller. So theoretically, the dimension of the bin is going to be smaller. That is why the industry of the timber, so also who produces the machine, is working on different approaches for creating wider bin, using staggered glulam, or you need to give, let me say, medication to the trees or plant them in a specific way. So we are managing the forest first of all in a sustainable way, but quite actively, because the way you harvest the trees, the way you treat them while they are alive, changes quite dramatically the strength and the stiffness of the log. Because for structural application, if you look at the log, you know that you have the growth ring. But the timber to be used as a structural material must have not those growth ring in the lamination. They must be straight. The result is that you can use only what is called tangential lamination, only those at the peripheral part. So everything is in the middle is not interesting for the structural purposes. Fortunately, you can use that part of the wood to create clothes and paper as well. Thank you for the question, by the way.
Yeah, good point. All right. So thanks, Simone. It was really, really nice to have you here. You had a lot of questions, so
Yes.
great. Let me close this last design lecture for 2023. Next semester, you will be back your hometown. Feel free to join our lectures if you are overseas, because they will be always published online on LinkedIn, Facebook, and stuff like that. So you will have a chance to follow. Yes, live streamed. It's a bit early now, but you will have a chance to follow the Rome Center even if you will be far away from us. So thanks again, guys. Go now back to your final exams and good luck for everything. And thanks again. Bye.